So today's speaker is Dr. Marcelo Emilio from Sao Paulo, Brazil. He's actually at the University of Ponta, State University. And Dr. Emilio's been coming to Hawaii for about 10 years working in solar physics with Dr. Jeff Kuhn. He also has interests in open clusters, hot stars, transits, planetary science, and I'll let
good evening, everybody. I will try to speak slowly because my accent, and if I speak too low, the people from behind can alert me, okay? And I try to speak loudly. You can interrupt me anytime. No, just raise your hand. If I know the answer, I will try to answer. Okay. I will talk a little bit about our solar system, almost all bodies, and will be a little longer because of that, but I will try to be fast. And discuss about the definition of a planet and difference what a planet and a dwarf planet. And finally, I will talk about my own research, about some participation in a big group, about some trans-Neptunian objects, those dwarf planets that you heard about. This is one of my fields of research. You are used to know solar system like that. Before we have 9 planets, and now we have only 8 planets, 5 dwarf planets, and more about 75 candidates to be dwarf planets. Well, if you not change the definition what a planet is, probably today we are going to, or a few years from now, to have 20, 30, or 40 planets in our solar system. Here's what the solar system used to be: Sun, Mercury, Venus, etc. And now we have, like this, 8 planets. We have dwarf planets between Mars and Jupiter. The other 4 planets they are beyond Neptune. Okay. I will talk a little about everything. Oh, this is an image I like to show always. It's image of the planets in scale. And you see the Sun here, Jupiter, Saturn, Uranus, Neptune, and here Earth. Yeah, and could you guess what object is this? No, this is Mercury. Yeah, and I like to show also this image because it looks very much our moon. And this bigger image, Mercury, and I will switch for this software that I like it so much. Yeah, this is the Sun. And this is Mercury. I will not talk so much about the Sun today. Yeah, see if I can. This software is called Celestia. You can download, just Google it, and it's a free software. Yeah, he's. I can show you the orbit if I want. I will. You can put real time if you like. Yeah, you can.
That page had all the planets. And the dwarf planets, there's Pluto, and there's a couple, there's Haumea and Makemake. Are those
a dwarf planet? Yeah. I will talk about those too. Yeah, okay. We start with Mercury now. think it's T that you like. Okay, and you are seeing the face of Mercury that's day. If I can, no, I cannot show here on this one. Okay, but the time that Mercury takes to orbit the Sun is comparable to the time that Mercury takes to rotate itself. Like the day in Mercury and the year, they're almost the same size. 2 days in Mercury is bigger than year in Mercury. And Mercury is very hot. The face is facing the Sun. It's very hot, about 300 degrees. And the face that is night in Mercury is minus 100 degrees Celsius. Okay, and Mercury also don't have an atmosphere. And those images I show you, it's from a spacecraft that's now orbiting Mercury. Now this is the last most improved image from Mercury now. Okay. We have an idea of the composition of Mercury. You can compare with our Earth and the Moon. This is Venus. Okay, Venus have about the same size as Earth. It's comparable in size, and we cannot see the surface of Venus because the atmosphere is so big, and Venus is so hot. You know how many degrees we needed to cook bake in the oven? 50. This is not degrees Celsius. It's Fahrenheit. I used to Fahrenheit. Yeah. The Celsius will be about 3. Yeah. It will be for me about 300, 280 degrees Celsius. Yeah. And Mercury have you can have 400 degrees Celsius. You cannot oven bake in Mercury without ovening, but you will melt your oven because it's enough temperature to melt metals. Okay, and it's too hot. Have atmosphere, but it's not good for us. It's a spacecraft who send radar waves Venus, and we map Venus now. These waves pass through the Venus atmosphere, and we have a map of Venus now. Venus, these blue ones are not oceans, are only regions that are lower in Venus. Okay, but we can see like mountains in Venus. And here's the map of Earth. And here's a map of Venus. You can compare. They are about the same size. Yeah, look like this continents in Venus. Yeah. The blue is not water, just lower regions. Yes. And this is a volcano in Venus. A map. Earth. Okay, you can recognize the continent here. It's Africa, yeah, Madagascar, and South Pole, yeah, Alps. This is Earth at night. It's also very interesting. This is a composition, we said, a mosaic of several images of Earth taken during the night, where there's no clouds. Yeah, you can see how US is bright, yes. You can see Hawaii on this. And Africa, you can see how dark the desert is. You can see those lights. This is the Nile River on Egypt. Okay. Here, Russia, you can see very dark, and this is a road that traverse Russia. Okay, and the center of Australia is also very dark. Japan is very bright. You can see how many people there's in India. Yeah, and Canada is all dark up there. Yeah. Okay, this is a real picture showing the moon and the Earth. Okay, and you can see the side of the Earth that's day and the side of the Earth that's night, as well in the moon. Someone know what this picture is? Okay, still have a question. An eclipse, yes. Thank you. Okay, this is the shadow of the moon in the Earth. And if there's someone in this region, the Earth, they will see a total solar eclipse. And someone is out of this shadow, they will not see eclipse at all. They will see only the moon close to the sun. But the moon will not be over the sun. This is a hurricane in Earth, and I would like you to keep this image because I will turn to this image later when we saw Jupiter. Earth has a magnetic field, you know that. Because of the interaction of solar particles with our magnetic field, we have the aurora. Yeah. Some map of volcanoes on Earth. Each red dot points a volcano. And the light blue line is the tectonic plates. Yeah, and the volcanoes, you notice that they are in these boundaries. Yeah, when the plates move, we have earthquake, and also where the volcano is. Okay, the Hawaii volcano is a different formation. I will come back to that image later too. And this is the moon. Yeah, this is our moon. Is the only object besides Earth that the man already visited. Is on the footprint of Neil Armstrong. This vehicle was left in the moon, and some years ago, another spacecraft that's orbiting the moon, it photographed the place where the Apollo mission were. And you can see the track of the books and all the material that was left on the moon. This is for Apollo 17, but if you Google, you find for the other missions. Okay, this is Mars. Mars has half of the size of Earth. Mars has seasons as Earth have. You can see the pole of Mars, this white dot, and there's some ice there. Okay, but most of the blank you are seeing are carbonic gas, frozen. Yeah, and the size of the pole grows and will be smaller. It depends the season on Mars. The picture taken Mars, in fact, by spaceflight. This is Viking on 70. Okay.
Does Mars tilt on its axis? Is that what causes its season?
Yes. Yes. It's very similar to why Earth has season. It looks like a desert as in Earth, yes. And the mission was designed to try to look for bacteria, some forms of life in Mars. Yeah.
How did you get this? How did you get this picture? Because most of the time when you take pictures in places in outer space, they use different
Yeah, this is about the color of Mars really is. It's iron oxide in the surface, and the Mars have this orange color because of that. We have robots still working on Mars. What's the biggest mountain on Earth? Yeah, Everest.
Yeah, right.
Mauna Kea. Okay, if you count from the bottom of the sea, I agree. Yeah, yeah. Okay, this is the biggest mountain on Mars. It's 3 times the size of Mount Everest. In fact, it's the biggest mountain in our solar system. It's also a volcano.
Is it active?
No, no.
That's 90,000.
Huh? I don't think it's hard to me to fit in.
Yeah,
Fit
9,000, which is 30,000 meters.
30,000 meters. Yeah, it's 20. The number is 27,000 meters for this mountain, yeah. And it's 500 kilometers across. Okay, I will back to my program. Show Venus. See if I have some. And then Earth. Yeah, it's too fast. Yeah. And then can find the moon. And this very high resolution image that I found today from on the internet. Yeah, it's something interesting I would like to show you. This in red is the orbit of the moon. Here Earth, and blue is the orbit of the Earth around the sun. And see how close the moon is from Earth. Okay, this is on scale. It's the first time I think most of you will see Earth, Moon, and the Sun on scale. The Sun will be the center, yeah. Okay, this is orbit Venus, Mercury, and the Sun is center. And you see, we can even notice the orbit of the Moon around the Earth in this scale. Mars. Where? Those ones? Yes, yes, as meteor equators.
So what happens to the meteors? I mean, they're not a center of the circle. They're just obvious.
Yeah, yeah, they disintegrate. Most of them disintegrate. Some we found a piece of meteor sometimes. It depends how the angle and how big it is.
So do they just like start to ask us?
No, 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 no. I'm here for that.
If they're really hot, you would see why they would disintegrate because they're going through an atmosphere. But some of these planets don't have atmospheres, right?
Yes, yes,
In fact, the moon is close.
yes. But it depends the size. Like the one who killed the dinosaurs, our atmosphere has no difference because it was so big that even noticed that it was. This one was 20 kilometers. I don't know. Can you someone convert it feet? No, 20 kilometers. 35,000 feet. Yeah. 20 miles. Okay. 20 miles. 12 miles. Okay. When the meteor hits the surface, it was the other part of meteor was 12 miles above. Yeah, this is the killer one. Yeah. Yeah, I have a movie to show you. It will take more time. I will leave this movie to define, okay? Because the simulation, what happened when the meteor hits the Earth. If I forget, you please remember me.
One thing that puts it in perspective for me is that at the average speed that the meteors impact the Earth, that it has approximately 400 times its weight equivalent energy of dynamite. So it's very energetic. And so it doesn't have to push against the atmosphere or anything like that to burn. In fact, the atmosphere actually pushes the impact a little bit. Pardon me.
Back to the moon, only to make a note. If you see the surface of the moon and the number of craters that the moon has, okay, there, and you can think the number of impacts that Earth has is the same, proportional. But here, okay, what?
Model comet 9P Temple 1 and Anthony's got a...
You have a meteor. Wow, how nice. It's iron, no? Because it's a dark one. Where you found it?
What?
Where you found it? You found it. JD found it. Ah.
2 minutes ago.
Both? Okay.
The comet?
No, this is just a model. Just a model. Yeah. Yeah. We can think we have as many impacts as have in the Earth as have in the Moon. Only difference here we have wind, we have rivers, water, vegetation, yeah, and this went away. Okay, back to Mars. I have better one. Okay. And here you can note in the surface of Mars a big canyon. And this canyon here is about the size of US from one point to the other. I don't know if someone can help me here. I don't know how it was formed. Yeah.
You know how all the meteorites are hitting like the moon and Earth? Was there a window in history where it was more occurring, or it's just randomly over time?
When solar system was formed, you have not planets yet. You have small bodies. We call it planetesimals. Okay, and during the formation of the planet, the planetesimal, they hit each other and make what we call protoplanet. And still, the protoplanet that have a very elliptical orbit, they collide with each other. And the Earth, it collides with another protoplanet of the size of Mars. And this is when the moon was formed. The moon was formed with the same kind of rock that Earth is formed. Okay, and then the solar system was stable by some sense, and not so much collision occur. I will talk more about that because this is when the planets clean the orbit. It is some definition of planet. I will talk about that later. Okay.
The oceans are like, weren't they formed by a bunch of meteorites in the earth that they think may have had a little bit of water in it, but after a couple million years of it being repeatedly hit by these meteorites, they created the ocean?
Yeah, there's a theory that the Earth, the water on Earth, was created by collision of a comet. Comets are like ice, and some calculation just some millions of years was enough to form our water on Earth. But it still is not confirmed. There's a scientist in Oahu, David Hewitt. He's not there anymore, but you know, he talked about the hydrogen on comets. It's a little different from the hydrogen that have on the ocean. Yeah, because you can. I don't want to be in details, but you can have the nitrogen atom with just one proton or one proton on a neutron. And we call both hydrogen. Okay, but you can comets are different from where there is in the ocean. Okay, I would like to talk about the moons on Mars. Mars have 2 moons. Should okay, these Phobos. See, I like to show you how close of Mars this moon is. Okay, and sometime it will fall in Mars and will create another crater. And this Deimos. That's not also far from Mars and the orbit. Oops. Yeah, yeah, you reach there. Yeah, see, it's not so far from Mars also. Okay, to be like round, the celestial body have to have enough mass. Then the gravitational force make it round. If a small object will not be round, but if a big one have enough mass, then the gravity try to concentrate it to a minimum state of energy, we said. And this will be the round shape. This is why by the superficial tension, the drops of water are round too, because this is a minimum state of energy. It's like if you have elongated object, they try to push, you know, until be round. And this is a condition to be a planet. I will come back to that later. This is a very good question. They both are. Okay. Then between Mars and Jupiter, that's the next planet, we have a belt of asteroids. The biggest object is called Ceres. This was considered just 6 years before the biggest asteroid known. But we don't call Ceres anymore asteroid. This is now a planet. It's a dwarf planet. The first one we are going to see today. It's a dwarf. And the biggest, yeah, this is round, yeah. Okay, this Pallas, this is the biggest asteroid known today. Yeah, and have about 600 kilometers diameter. I like those asteroids, and you show some more. This is Ida. There's a spacecraft who passed very close to this, and you can see features, you can see craters in Ida, see? But if you only pass here, just in front of it, if you turn it, we have no information, we have image taken from the Earth. No? But there's something else about this asteroid. You see this little point here? It's another asteroid. It's called Q. And Q, it orbits around Ida. It's like an asteroid with his own moon. Okay, I will show you another asteroid. The official name is Cleopatra. I would like to try to it have a second name. But I would like to try to find out what's the second name. It's not a good angle. Yeah, dog-bone asteroid. Exactly. Yeah, this is Jupiter.
What was the name of the dog one?
Cleopatra. The name of the Queen of Egypt. Cleopatra, yeah.
Why they choose Venus? That means there's another thing from Greek mythology. It must have been that.
I don't know. Oh, the the International Astronomical Union have some rules to put names on objects. Like planets can have only have name of gods, but asteroid you can name after one person. I know some colleagues who are named after asteroids. Are you have an asteroid in your name? No. Not yet. Okay, this is Jupiter. We call Jupiter a planet still. But I will tell you that's a different object. We met planets that are solid, rock, have few moons, are small, rotate slow, have few or no magnetic field. And this is completely different. Most of this planet is just gas. Yeah, maybe have some liquid or solid nucleus. And remember the hurricane I show you. This is a hurricane in Jupiter. It's called Eye of Jupiter. This one. Okay, only inside the Eye of Jupiter it's possible to place 3 Earths. Yeah, and someone knows how many moons does Jupiter? Okay, we have a question. How many moons? Oh, this is why I asked first. Well, someone more? Okay, let's remember the moons case. How many moons have Mercury? Did I show some moons of Mercury? No, it's probably Mercury don't have moons. 0. How many moons have Venus? 0. How many moons have Earth? Only 1. How we call it? Moon. Moon. Mars? 2. Remember how we call it? Deimos and Phobos. Okay. Now Jupiter. How many moons have Jupiter? Yeah, over 60. Yeah. Yeah. The official ones number is 50, but we have about more 14, no 13. That's about to be officialized. Okay. And I just heard some 2 or 3 weeks ago, some new moons that was found out. They lost now. They don't know where they are.
So I assume that moons are because of the gravitational pull.
Yeah.
So Jupiter has so many for such a big mass.
Yeah. Yeah. This is the biggest planet on our surface. Yeah.
And what are they made of? Are they gas also, or?
They're rock. I will show you some. Yeah. And they would like to show how the orbit is around the. Look, Jupiter has his own planetary system, no? Yeah. Okay.
Wasn't it a couple of years ago hit by a comet? A comet they hit a couple of years ago, and it kind of had ripples running along it.
Yeah. How many years you had in 1994? This is when the comet hit Jupiter. The name of comet is Shoemaker-Levy. It hit Jupiter from behind. We cannot see when it hit, and it forms like clouds on Jupiter in the place where the pieces of the comet hit. It was visible for months. If this comet hit Earth, it would be in a big trouble. Jupiter protects us against some of these impacts because he has so much mass, his gravity attracted some of the asteroids for him instead of coming to us. And I will begin with this one. This is the biggest moon of our solar system. It's called Ganymede or Ganymede. Yeah, and it looks like our moon. Yes. Have Callisto. Also. Huh? And Ganymede. Ganymede, yeah. Sorry for my accent. Yeah, and this looks like most of our moon. Yes.
The biggest moon you just showed us before that, how big is that compared to Earth?
Okay, Earth has 6.2 thousand kilometers. The moon, I think, have about 500. I can't come back there because 600. Yeah, it's written here. No, it's 2.6 kilometers, and the Earth has 6, about a factor 3 in radius. Yeah, but it's bigger than Pluto, much bigger than Pluto. Yes.
I don't want to go so much about chemistry right now since we're talking about the solar system, but I heard something about Jupiter having a metallic hydrogen core.
Is that a question? I did not understand your question.
Do you have any information on that?
On the core of Jupiter? Yeah, I saw already two research. People know that Jupiter would have a solid or liquid nucleus, but some scientists say that they have only gas.
What kind of solid? You said
No, it's could be hydrogen liquid. Yeah, or like iron, solid iron. That,
So if the nucleus is all gas, then wouldn't have Schumacher-Levy pass through it, or no?
oh, because it's a big quantity of mass, and even if a gas has gravity, yeah, and it can think like a meteor hit Earth, or if the spacecraft, the the bus, the NASA bus, will enter in our atmosphere, they need to have a special protection about the heat. Yeah, but in Jupiter it's much worse. Yeah, it just will appear. Yeah.
I was wondering, is there any like moons with like moons of their own, like stuff orbiting, like moons orbiting planets?
Moons over moons.
Yeah.
Moons orbiting moons. We don't. I don't know any moons orbiting moon. I show you a moon or an asteroid orbiting another asteroid. Yeah. Yeah, but I will show Charon and Pluto, and these like two planets orbiting themselves. I will go back to that. It's interesting.
Also with the Pluto and the other planet, there are also a couple. I'm pretty sure there's two other planets near there that were also orbiting. They're in the same orbit.
Okay, hold your question for Pluto when I show Pluto, okay? Because I will show Pluto and the moons too. If I forget you, please remember me. This is Io. Okay, and remember the volcanoes are shown on Earth, the red dots. And this is a volcano on Io. But the volcanism processed in Io is different from Earth. Io don't have tectonic plates. You have a magma, the liquid rock in the interior of the moon, and it's attracted by gravity, by the Jupiter gravity outside. And this form, this is another very nice volcano here. It's Europa. It's another moon of Jupiter, and this moon is all covered by ice, ice from water, and below this very thick ice have an ocean of liquid water. We know that. Who knows? Maybe we can fish one day in Europa. And these are cracks on the ice you see on Europa. Okay, it's also made by the gravity of Jupiter, and they open and close. Hmm? Oh, probably salt. Yeah, I know that because I will show you another moon in Saturn, and they found also similar to Europa, but have geysers on that. What is coming? I will go back to that and tell you. Okay, and the four moons I show you from Jupiter are the moons that Galileo Galilei in 1609 he found out. Okay, and they call it Galilean moons. Okay, those are the four moons I show you now. And this is a close-up of Io to show you the volcano. You know, someone know what is this? Rings? No, the rings of Jupiter. Yeah, all the gaseous planets in our solar system have rings. Then Jupiter have rings, Saturn have rings, Uranus have rings, and Neptune have rings. Yeah, but the Saturn ones are the most visible ones. The Jupiter are only visible from space.
So even with a telescope, you can
No. The Saturn, yeah, the famous by rings.
What about, can you see this like from the Hubble? Those
Those rings, yes, yes. This is a picture of Saturn taken about 2 or 3 years ago by the Cassini spacecraft. It's like eclipse. The sun is behind Saturn. And it's a pity. You cannot see here, but you can see in the monitor. There's a little point here on Saturn. To just zoom in. Yeah, and this is the Earth, seen from Saturn. Yeah, this picture is very famous because of that. Just a point on the image. Okay, Jupiter also have in total 62 moons. Not all of that are official now. But this is very special. The second biggest moon in our solar system, only smaller than Ganymede. And NASA sent a mission to this moon because this moon have a atmosphere. You remember I showed you Mercury. And Mercury, you see the craters of Mercury because it looks like the moon, because Mercury has no atmosphere. This moon is bigger than Mercury, in fact, and have a atmosphere. And I will try to confuse you pretty much in this talk. What is a moon? What is a planet? You know, what's an asteroid? Because when you see in nature, the differences are not that big, in fact. We call that a moon because orbit around Saturn. Just because that, if you orbit only around the sun, we are going to call it planet. Okay, and together with Cassini spacecraft that studied the Saturn, there's another spacecraft called the Huygens. And in 2004, if I'm not wrong, it dropped by parachute in Titan. This is the name of the moon, Titan. And these pictures from Huygens, you can see when it reaches the atmosphere, and you can see some mountains, and finally it dropped. This is a real picture of Titan, of ground of Titan. This is the first spacecraft that landed in the outer solar system. And Titan,
Is there any one?
no, but have lakes. It's so cold, like gases that are gases here on Titan. They are liquid. And this is a map of the subsoil of Titan, and you can see those lakes. Yeah, it's organic gases on that. And this is a place that also we can find life because of that. So another moon of Saturn called Estadual. This is the moon I was talking about. I have these geysers, so, and it's all covered by ice also. And the process has a pressure here, and some water that is below the ice comes out. And the scientists studied those compositions. Okay. And we know that's water as we have on Earth, but salt water as in the ocean. Yeah, it's like a geyser. Yes.
They talked about sending a probe there to melt through and search under.
Yes.
Which
Yes.
one is more likely? Are they both good candidates?
I was talking about that with a colleague. She's not here. She just come back from mainland, from the Congress about astrobiology. And the scientists are now trying to classify the probability to find life. The first one is Mars. The second is Europa. And with this classification, Enceladus will be the 20th. The 20. 20, yeah. Okay, did I answer it? But these are not very well defined parameters. We're just scratching now, you know.
How much do they estimate energy will from heat will be needed to melt through the ice to get down to the water?
Out several kilometers thick. Yeah, and there, NASA was talking about this nuclear device to melt the ice, and then launch a submarine there. But it's a very polemic one to launch some nuclear material in space, you know. Maybe never happen. Okay, this Uranus also you have many 25 moons. Have a ring. It's a gaseous planet, it's a giant planet, and a peculiarity about Uranus that the pole faces the sun. It orbits like that. The pole is facing the sun all the time. Oh, the peculiarity about Venus that I forgot to tell, that Venus rotates in the opposite direction as the others. Neptune, also a giant planet, a gaseous planet, have an eye, as have Jupiter, so, hurricane, have rings. I can show you in my problem the rings of Neptune later. And Neptune is blue by the same reason the atmosphere of Earth is blue, have a lot of nitrogen on Neptune. Okay, then we reach Pluto. Yeah, I show you all the no planets today in the solar system, yes? And I begin to talk now about the dwarf planets. Okay, this is an official definition by International Astronomical Union what is needed to be a planet. Okay, first it needs to orbit around the sun. Have to enough mass to assume hydrostatic equilibrium, or else be wrong, as we talk about. And have to clear the neighborhood around its orbit. It needs to dominate the orbit. And this is not so clear definition as I will show you. And to be okay, and if you orbit around the sun and it's round, but not clear the neighborhood, we call it a dwarf planet. Yeah, that is the major object around his own orbit. But some scientists contest that. I will try to explain. Remember, in the beginning of a solar system, we have a lot of planetesimal. This is just simulation. And with time, there are collisions, and the planets decline with their own gravity. The rest of the bodies, or the bodies will hit the planet, or will be expulsed, will be thrown away. Okay? But some scientists contest that, saying, for example, Earth, we have a lot of near asteroids around Earth. Then Earth cannot be defined as planet because not clear his orbit. Or Jupiter has some asteroids called Trojans also, and they mean, oh, have the Trojans there. That means that Jupiter also don't clear this orbit. We have Pluto, what means the Neptune don't clear his orbit. Okay, some scientists try to agree like that. Okay, but if it orbits the sun, have hydrostatic equilibrium, then it's a dwarf planet. And with this definition, we have now 5 dwarf planets. I show you one that is Ceres. Then we have Aries, Makemake, and Haumea that was found on Hawaii. It receives a Hawaiian god name. They cover everything. Haumea, Makemake, Aries, and Pluto. Yeah, Pluto become a dwarf planet in this classification. Okay, it's a very tedious table that I decided to add just to show you how confused it is to define a planet. Okay, in this column here we have the same major axis. This is about the same what we call the distance from the sun. Yeah, all the numbers are related to Earth. Then the Earth is 1. If the number is below 1, it means that it's closer to the sun. And like Uranus, it's about 19 times farther from the sun than Earth. Okay, and the red ones are the rock planets. The planets that are close to the sun and they are similar to Earth. And pink ones are the gaseous planets, the planets that are similar to Jupiter. But IAU do not recognize this classification. We call all planets, but they are very different objects. Those are rock, and those are gaseous planets, most gaseous. Those are close to the sun, and this is farther from the sun. Those don't have rings. Those have rings. Have smaller radius. Those have bigger radius. Those don't have a strong magnetic field. These ones have a strong magnetic field. You see the number of moons. As I said, Mercury has 0, Venus has 0, Earth has 1, Mars has 2, and Jupiter has 66. Saturn has 62, Uranus has 27, and Neptune 13 up to now. The rotation, okay, the negative signal here is because, as I said, the Venus rotates in the opposite direction. And you can see the density here. The high density means rock planets, and those are gaseous planets because this is low. And you can see Saturn that's below 1. That means that we have enough big ocean. So we put Saturn will float because this is lower than water. And finally we have the dwarf planets here in blue. Pluto, Haumea, Makemake, and Aries with the numbers. We don't know if Makemake or Aries have the rotation or even have more moons. Just last year we found one more moon for Pluto in June last year. This was your question, yes? Color P4. I talked about that. Here's a Hubble Space Telescope picture of Pluto, showing the 3-1. I forgot. Okay, I have the other one that taken in June last year. That are the 4th moon of Pluto now. The P4. Okay. I have some slides to explain that. Just hold your question. Okay. To complicate even more, you remember about the hydrostatic equilibrium that the body needs to be round. We have 19 moons that are round in our solar system. that the Earth moon is round, the 4 moons of Jupiter that I show you is round, and Saturn has 1, 2, 3, 4, 5, 6, 7 moons. Uranus has 1, 2, 3, 4, 5 moons. Triton has 1, and Pluto has Charon. That's also round. If all those moons were just orbiting the Sun, were not orbiting his planet, all of these we are going to call planets, or dwarf planets. And Charon has a peculiarity, it's even more complicated. Someone have a question? No? Yes. We don't call Pluto a planet anymore, we call Pluto a dwarf planet, because he do not dominate the orbit, he not clean his orbit. Okay, I try to explain further this. A long time ago. I can imagine. Okay, there's something called center of mass. Yeah, in the homogeneous object, you'll be like is the point where you can equilibrate it. Yeah, this is only a toy that's not uniform. But when you have an orbit, you can imagine 2 planets or 2 stars or 2 moons as you wish, and have the same size and same mass. And they will orbit in ellipse. You share a common focus on the ellipse, a common point where they orbit around. When one of the objects is bigger than the other, that means that the ellipse will be smaller. And the point here will be close to the bigger one, as in this case. Okay. Then we said that the small object, it turns around the bigger one. Okay? Only because of the gravity. But the bigger one also orbits around the have an orbit, but the center of orbit is inside himself. Then we just see his wobble. Yeah, and this is the technique to find exoplanet objects. This is the way that we found planets outside our solar system. We don't look at the planet, we look at the stars, and we see if the stars have this wobble. If it's even bigger, then this point is even closer to the center of the star. Okay, and we can okay, this is star, this is a planet orbiting around. That's okay? And remember, I told you that Charon have hydrostatic equilibrium, is round, and his orbit around Pluto is like that. The center the center is not inside Pluto; it's outside. All the other planets, if you take like Jupiter or Earth, the center is inside the Earth, for example. On the Moon, around it orbitates around, or the Jupiter, the center of the orbit of all moons of Jupiter is inside Jupiter. But for Pluto, it's outside. Okay, and the astronomers try to use that as a definition of what a planet is. But it did not work out, because if you take the system of the Sun and Jupiter, this point is outside the Sun. Okay, and for Charon and Pluto, you can see, okay, if they already try to call Charon a planet too, because this is like a double planet. Charon have 1/3 of size of Pluto. It's like a double planet. Okay, or now a double dwarf planet. But I would decide to not classify like that and call Pluto a dwarf planet and Charon a moon. just by definition, but there's not a logical reason to do that. They're more like a double planet, or a double dwarf planet. Yeah. Yes, yes. 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 I will show you some research I have on Charon that we measured the radius of. But yes, Pluto is smaller than the Moon. Yeah, Pluto is very small. Pluto is smaller than our own Moon. Pluto also has a very inclined orbit around the Sun than other planets. That means the formation of Pluto is not the same as the other planets. Beyond Neptune, you remember I told you about a belt of asteroids between Jupiter and Mars? You have a second one beyond Neptune. It's called the Kuiper belt. Have many asteroids, many objects. And probably here we have about 75 objects that can be classified as dwarf planets. We don't know yet. We have like candidates. And those like candidates because they don't know if they are wrong. Okay? This is why they are candidates. But in few years, when we have our measurements, we can classify them as dwarf planets. Some of them. And then we are going to have maybe 20, 30, 40 dwarf planets. I made research of my own with a big group of some of those objects. I'll show you the first one. The technique is called occultation. Those objects are very far to have image, to have many pixels to see if they're round or no, to measure the diameter. They fell in a few pixels. And what we do is we weight the object to pass in front of star, and we will occultate the star. They will turn off the star. This is okay. This is Pluto. This is Charon. Okay, and sorry. This is Charon plus the star, and Charon pass in front of the star, and the star like turn off. I have a movie here to show you how it works. Okay, here's the light of star. Then Charon passes in front of it. It takes some minutes, and then the star come back to have the same bright as before. You will see here in this movie that will disappear and they appear again. Some minutes, 6 or 5 minutes. Those are fast ones. And for Pluto also we have more data, but for other occultation that we show you, we have very few information about. And we have a very not a good precision when or where the occultation will take place. And this is why we have to spread several astronomers around the globe, and by luck some of them will watch this occultation. No, this is a strategy. Those papers have like 60 or 40 observers each one. Okay. This was the one published on Nature in 2005. Oh, you see it disappeared. And we are going to have a shadow made by the stellar light. The shadow will have the same size as the planet or the object itself on the Earth. We have many people observing. Some of them will observe like this part of Charon, and others will observe another part. And this research results in the most precise up to now measurement of radius and density of Charon. Aries occultation, this is another dwarf planet. It takes place in November 2010. I have 2 nice movies. This will explain better what I talk about. It starts. Yeah, it's moving. Yeah, and you see the shadow of Aries, just animation on Earth, and it passed here in Brazil. Yeah, you see the shadow? Yeah.